The figure shows an empty container and an observer eye. There is a small coin at position O. The observer is unable to see the coin. The observer and the coin stay in the same position and the container is filled with water. The observer can now see the coin. Why the coin can be seen by the observer? Let me fill some water in the container, and water is a medium. Water is a medium. Do you remember the famous example which every teacher gave? The example of a pencil, which is
The
pencil.
water.
It is submerged in water and it appears to be bent.
Yes.
Why the pencil appears to be bent when it is submerged in water?
Diffraction.
Refraction. When waves move from denser to lighter, the waves bend away from the normal. I hope you're writing with me, right? You will improve a lot if you write with me. In a sense, you're also making revision, because writing in your own hand gives you a revision. These topics are some months back, maybe you did it last year. So there is a memory issue always. So now if what happened, if water is there, the wave will bend. Now the wave will bend, and after bending, it will be able to reach the person eye. Look at this explanation. Now this is the thing. I will give the example of a swimming pool. When you stand near a swimming pool, you will get the same issue, that the image is tilted. Why this happens? That actually waves are able to refract. When refraction occurs, waves bend. When refraction occurs, waves bend. So what should I write here? Due to refraction, light ray away from the normal state the name of the wave process which occurs at the light passes from the water into the air. Explain why the image of the coin is a virtual image. So why what is the virtual image? Can you hear me?
Yes, I can hear.
So what is a virtual image? Actually,
Image that is formed on a screen.
it is not formed on a screen, and this image is actually if I extend my ray inside, you will notice that the ray is reaching here, which is a higher position, than the actual coin. So the coin will appear to be here, and it's a virtual position. So the coin will appear to be here. This is called virtual position. Actually, the coin is not there, but due to the bending of light ray, it appears to be here. So why the image of the coin is a virtual image? It is not formed by it is not obtained by the actual intersection of light ray. Just like you're sitting in a class and you're looking at a projector image, it is a virtual image because the image is actually forming on the screen and then coming to you. So it is a virtual image because it is not formed by the actual intersection of light rays. State the speed of light in air. What is the famous number?
3.9 times 10 power.
3 into 10
No,
power 8.
3 times 10 power 8 meter per second.
The refractive index of water is 1.3. Speed of light in water. So let me show you the formulas again. It would be better if you copy down the formulas and make a box.
It's the switch.
So please copy down the formula list.
Okay.
Have you copied it?
Yes.
Okay. Now, can you repeat the formulas for me? Can you repeat the formulas? And I hope you're copying down everything. That's right, right?
For this one, we can use n is equal to sine I divided by sine r, right? Refractive.
Refractive, but he's asking for speed.
Oh, speed. Okay, okay. So for
So
this one will be The one in which we have speed.
The refractive index of
Sine inverse of 1.3.
sine inverse of 1.3. Why? But we need a formula somehow, V1 upon V2 or something like that.
So which one will be from that list will be used here?
Yes, this is the list I show you. But I repeat, I hope you are copying
No,
everything.
I am asking which one from this
No,
list will be used here.
I'm asking, are you copying the formulas, copying the word, right?
Yes.
Okay. So then you have to identify the formula from this list. Let me write this also for you.
No, I have written it. I have it. So
You have copied it. N is equal to V1 upon V2.
V1 upon V2.
Look at this working.
Yeah.
So please copy in your past paper book. And for midterm, you need to have a good practice because you can make a partition, you can make a proper space. Now copy down this formula. And please try to be quick. It's only a single step calculation.
Okay. Done.
Now complete the calculation, please.
One minute, I'll get my calculator.
Okay. But are you back?
Power 8 divided by 1.3. So it's coming like 2307626928
Convert it into scientific notation.
Sir, how?
Now you have a button on calculator ENG. A small button ENG, small button series ENG. So
Into
press that.
standard.
Is it a Casio machine or is it any other?
Casio FX 991 ES.
But this is Casio, na?
Yes.
So press the ENG button.
Okay. It comes to 30.76 times 10 power 6.
Oh, acha, press. I need decimal after one digit. So shift ENG. Press the shift button and then press ENG.
So wait, I'll do it randomly. I know how to make it standard form.
Very good. 2.31.
2.31 times 10 power
8.
8.
Now this is the presentation. Now I have written in front of you. The point is that it's midterm or mock or whatever, you have a full exam type thing. And if there is any improvement needed, electromagnetic induction is there. I have opened June 2023, the latest paper. Can you open this paper? I have sent you this paper on WhatsApp yesterday.
Yes, sir, there were so many. I think with the marking scheme.
But 41.
Which one of them should I open?
41. 41, June 2023, 41, question number 5. The figure shows a block ABCD. You can see this block made of glass that has a refractive index of 1.5. The block has one curved side AB and 3 straight sides BC, CD, and DA.
This is a bit high order question, right?
This is a bit challenging question, but this is a technique I told you last time that all people are doing some older questions, some very new questions because time is very limited. So in one topic, a student cannot do all the questions. The time is not there. Everyone is getting 9 to 10 chapters. Even some people are getting more. So the plan is that you should do some questions from 2019, 18, some from 2023, and some from 2012, 13. So I just an average. So suppose I tell you an average, for example, 10 paper 2 questions for every topic. That will help you to initiate the working. Now, this is a monochromatic light. It is getting in the block, going straight, hitting the point P. Some of the light is coming back and some of the light is going on the other side in air. There are right angles at C and D. The curved side AB is 1/4 of the circumference of a circle that has its center at point P. The curved side AB is 1/4 of the circumference of the circle. A ray of monochromatic light enters the block through the curved side AB and strikes the sides BC and P. Some light emerges into the air and some is reflected. What is meant by monochromatic?
A single ray of light.
No, half accurate, but not correct perfectly. Single wavelength. Monochromatic means single wavelength. Explain why the ray of light does not change direction when it enters the block through the side AB. Look at the side AB. When light enters here, you will tell examiner that it is striking at 90 degree. It's a 90-degree case. Let me draw a tangent here. Look,
Can
I
you
have
give
drawn
me-
a tangent.
Can you give me a minute? I'm just coming back.
Hmm?
1 minute, I'm just coming back, okay?
Again, I emphasize neat working in a good practice for especially this chapter. I have drawn a line on the so please quickly draw the line.
Does it must to draw a line over here?
Otherwise, you can't explain it now.
Like, it's not mentioned in the question to make a line somewhere here.
No, they will never mention, Amma. This is an international exam. So they will never mention. Achha, let me know if I do not draw this line, can I mark 90 degree on a curve? I can't draw a 90 degree, which is a part of my answer on until I draw this tangent. Now I show you the answer, okay? The incident ray makes 90 degree of angle of incidence. So it does not change
Sir, I'm writing it just like this. So I'm taking a screenshot of it because like I don't have this paper printed with me right now.
doesn't matter, but I told you that if you have if whenever you have a class with me on questions, you can keep a gadget, like any gadget which is writing aloud, which is like an iPad or anything. So you can save it on it and you can share the answer with me directly for checking. So it will be easy because everyone is doing now these techniques because no one can print these so many papers, March, June, November, is just like a bunch of papers now. And new papers are necessary also. So if it is possible, arrange that. Otherwise, it's fine. Show that the critical angle for glass of refractive index 1.5 is this. Let me write the formula. N is equal to 1 upon sin t. Sin t is equal to 1 upon n. Make sure your calculator is in degree mode. It's very important in this type of question.
So which mode?
Degree.
I didn't know about this mode. I'll see what's this mode.
Because you in your normal maths there is nothing like that, but this is the problem where some people make a mistake somehow by pressing random buttons. Sometimes calculator mode is changed and that can cause a big problem. A small deg or d is written on the screen, small deg or d, only d.
On the top, right?
On the screen, lower on the screen.
I usually before exam clear all the functions on the calculator.
That's a very smart thing, very smart thing. But degree mode, sometimes mode does not clear and mode remains. So that is why, but you have a good machines too. I hope that doesn't matter. Now, can you help me in solve, copy down these steps and help me to get the answer?
I mean, words of one or okay.
Yes.
$41.81. 41.81.
48,
41.81.
42.81 or 41.81?
41.81.
Okay, good. The figure shows that the angle between the ray of light and line AP is theta, where line AP is a straight line. AP is at right angles to side BC. Angle theta increases to 45. Look at the angle theta.
Okay.
Angle theta increases to 45. What is the critical angle? What is the critical angle we just have shown?
52.
42. And
Yes.
how much angle is now here?
Over here is a 45.
So, is this angle exceeds the critical angle?
No.
Okay. 45 degree.
Yes.
45 degree is greater than 42. Angle of incidence exceeds exceeds the critical angle. Total total internal reflection occurs. What is total internal reflection?
And the critical angle is smaller than the reflect the theta angle.
Right? What happens in this total internal reflection? Does the light come back?
It bounces back.
Light when theta is 45, the reflected light strikes side CD. Where is CD? Okay, light CD. So let us extend this light. I have extended, huh?
Okay.
But now what will happen is he is asking that theta is 45.
Yeah.
So if this angle is 45, do you think this angle will also be 45? Angle of
Mm,
incidence is equal to angle of reflection.
yes, that's okay.
Then,
Angle of incidence is equal to angle of reflection.
then if I draw a normal, what will happen? He's asking what will happen to the ray of light, where it will go. And let me draw a normal here. Now I have drawn the normal. Using maths, can I write 45-degree here also? Parallel lines, alternate angles. So when the light will strike CD, the angle will be 45 and 45 is greater than 42. So again, total internal reflection will occur. So again, total internal reflection will occur. So you will tell examiner that again total internal reflection will occur. So I have removed it from here, and now you have to tell me what will occur.
reflection happen, right? I mean, total internal reflection will happen, right?
Again, total internal reflection will occur second time whenever the angle of incidence is greater than the critical angle, you will get total internal reflection. So, what should I write in the answer?
That total internal reflection will happen again.
Total internal reflection will occur again. Now, can you look for a question from your book? This was our latest question, but let's do a question a bit older.
Yeah, because mostly 2000